points that are operating on the same channel. Other people, and my preferred approach, is to move to the edge of the cell boundary and listen for co-channel interference there. And again, I'm listening for other access points that are operating on the same channel. If I'm listening on the edge of the cell boundary, I want to make sure that the signal strength that I'm receiving from another access point that's on the same channel is at least 19 dBm weaker than the access point that I'm currently under coverage of. If you're looking at coverage in a multi-floor deployment, I would also suggest that you check your measurements between floors as well. There are some deployments where if you place the access point and the antenna on the ceiling, you can actually provide coverage to the floor above as well as to the floor below. And that is illustrated in this diagram here with access point 3, where you can see is actually covering the area on floor 4. And similarly over here, access point 2 is actually covering this area here on the first floor, as well as covering area on the second floor. I've personally found this is very true when you're using omni antennas on the ceiling, that you'll get this spillover depending on the material that makes up the ceiling. And from experience, I've found that the patch antenna tends to propagate through the floors not as well as the omni antenna, although you still want to measure it just in case it's causing some co-channel interference between floors. And remember, when you're thinking about cell overlap between adjoining access points or cell separation between access points that are on the same channel, those rules should be applied not only on a floor but between floors as well. So make sure you're measuring not only coverage but also co-channel interference when you go between floors. So now what you want to do is you want to align your actual measurements with the measurements from your modeling tool. Because what you want to do is you want to walk away from the post-site survey leaving your customer with a model that maps close to reality, and that will enable them to manage the wireless environment and any changes that occur going forward. Now, the tool to manage a Cisco wireless network is the Cisco Wireless Control System. Now, if you did your predictive site survey using Air Magnet Survey, you can actually import those results into the Cisco Wireless Control System and then use that as a basis then for planning your network going forward. If you actually use the Cisco Wireless Control System to do your predictive site survey, then you're also in very good shape because that information, the floor layout, obstacles, etc., is already loaded into the tool. Now, you start that by making sure that the floor plans are accurate, that any obstacles are effectively drawn in on top of those floor plans. You'd make sure that your access points are correctly placed. Check the transmit power for each of those access points has been correctly entered into the models, and make sure, of course, the antenna types are correct and the placement and direction is also aligned with reality. If the model and your findings still don't match, then you'll need to calibrate the model. And most tools will allow you to put in measurements at various locations in order to further optimize that model to then more accurately predict what you're finding actually out when you're doing your measurements. So very important to make sure as part of your post-survey work that you align the actual RF findings with the model's prediction. So now you've ensured your coverage, your cell boundary, your co-channel interference, your sources of interference. You have a good model that you're using. Now's a good time to do what we talked about at the beginning and look at live data. And if you don't have sufficient live data, to actually inject data into the RF, because what you want to do now is you want to measure the data throughput. And this is referred to as an active survey. So just to remind you, a passive survey is when you're passively listening, and that gives you things like the signal strength, channel allocation, noise level, signal to noise ratio, etc. In an active survey, you will associate with the access point and actually send data frames backwards and forwards. Now, the Cisco Spectrum Expert is for a passive site survey. You can use the air magnet survey tool both in a passive and an active mode. The air magnet tool also has a different mode where it integrates with an iPerf tool. With the iPerf tool, you must deploy a server as well as having the iPerf capability in the client that you're using. And what it does is it allows you to record transmission rates both from the device to the access point as well as from the access point to the device. So it records the data rate in both directions. And that's what's being shown here on this slide. You can see is for the iPerf, and you can see the downlink traffic and the uplink traffic, where the downlink is from the access point to the client and the uplink is from the client to the access point. So now we've done our RF audit, now it's time to do our roaming audit. And a tool like the Air Magnet Analyzer collects statistics on all the devices that are roaming between access points, and that could be a laptop, a tablet, it could be an IP phone, or even a barcode scanner. And it collects that information about when the roaming is taking place, the channel parameters that actually triggered the handoff between one access point to another, and gives you a quality assessment as to whether that roaming experience was good or not so good. And based on that information, you can then decide whether you need to change something in the configuration, maybe alter the power level of the access point, restrict certain data rates, etc. Now, the way you check for roaming is you actually walk around the building or outside, and you walk where the user would normally walk. And a couple of best practices that may help you is first, do one band at a time. Do it for the 2.4 gigahertz band and then redo it again for the 5 gigahertz band. The reason is that doing both at the same time may seem like a good idea to save time, but you may lose some valuable data that you wouldn't do if you were just doing one frequency band at a time. So it's recommended that you do one band and then go back and walk again the same path using the second frequency band. The second best practice is don't walk too quick. If you walk quickly, you could actually miss valuable data. So take your time and walk slowly. It's better to have a bit more data than to have gaps in your data. And the last best practice is cover all areas. Don't assume that there's an area you don't need to cover. Some people think, oh, if I've got a floor plan and all the access points are down the middle and I walk down one corridor, I don't need to walk down the other corridor. But remember, RF is different and interference sources are different. So do not assume just because you've got a uniform layout that the measurements will be the same on either side of the access point or the same between different floors. So don't shortcut this process. Once you've finished this process, you'll probably want to fine-tune some of the power levels, data rates from different access points. And once you've done that and you're comfortable that you've got the best coverage, you're managing the interference sources, etc., the last step you want to do is to make sure that the actual customer applications themselves are working. You should try roaming with different types of devices, for instance. If you've tested out the roaming with a tablet, now you want to go back and make sure the roaming works with the IP phone, for example. Make sure you can use things like RFID tags, and as you're moving around, they're calibrating the location correctly. If you're using barcode readers, make sure that no matter where you are, you're able to send data, that none of that data is being lost. So essentially the last part of this is, once you've done the physical layer and then you've looked at your data rates at the next layers up, now you want to go up to your application layer and make sure the applications effectively work. So now we've been through the different steps of conducting a post-site survey. Now in this section, we want to look specifically at the Cisco wireless control system and the tools that it has that will enable you to make sure the network is ready to offer voice services and location services. So when we look at the wireless control system, the first thing we want to do is add maps of the location, both outdoors and indoors, the different floors. Now, if you use the Cisco wireless control system to do your predictive plan, well, you've already got that information already loaded. If you used the ear magnet site survey tool, you can actually upload your predictive plan to the wireless control system, and that will upload your maps and any obstacles, etc., that you've added in the previous process. Both of those two steps will save you time. If you don't have anything, then now you need to start adding it. You need to add the maps, start building in your obstacles, etc., with your map editor. You will bring in the types of access points that you're using, specifying the types of radio. Is it A, B, G, or N, or a combination? You'll bring in the antennas that you're using in your deployment. And from that information, we're going to generate a heat map of what the tool thinks your RF environment looks like. So I just wanted to remind you from the earlier demo of the Cisco wireless control system, when we generated our predictive site survey. And the reason I want to remind you of this is because we're going to use this tool to now check our voice and location readiness. Now, in our post-site survey audit, if you remember step 3, the goal was to align the information that we were finding in the field with the predictive model. So now that we have a map showing the site location, it's got the obstacles installed, it's got the correct access points in the correct location, the correct antennas, and the correct direction of those antennas. Now we want to go forward and use this tool to say, is this deployment ready for voice services and location services? Here, I just wanted to show you the different types of IP phones that Cisco has as part of their 792X series. So the Cisco wireless IP phones are very similar to the Cisco wired IP phones. The only difference is that they're going over a wireless network. So they must first authenticate and associate with the access point before they can actually obtain their IP address. So your 7172G handset supports voice calls and a range of calling features and has a wired headset. If you go to the 7125G, then you see the introduction of a Bluetooth headset. It also comes with a rubber case, which means your phone has some protection if it is dropped. The 7125G EX also comes with a Bluetooth headset, but is actually now further ruggedized in order to operate in a hazardous environment. That would include things like chemical manufacturing plants, oil refineries, etc., where it may be exposed to different types of fluids, etc.